Hello everyone. Now in this video we are going to see one more case of line inclined to both the planes and how to draw its projections. As on the screen you can see that a line PQ 80 mm long measures its top view as 65 mm and the front view as 55 mm, whereas its midpoint is 30 mm above HP and 35 mm in front of VP. Draw the projections of the line and determine apparent lengths and inclinations. Yes, this is exactly looks like the previous tutorial, but only one change is that in the previous question they gave the position of the end point P. P is fixed. Now in this case the position, the midpoint is stationary. That's why where it has written as, whereas its midpoint is 30 mm above HP and 35 mm in front of VP. Just in the previous tutorial the end P is fixed or stationary. Now in this case midpoint is stationary. So let us see. Given true length is 80 mm, the top view length as 65 mm, front view as 55 mm. Once again we will see. When a line is inclined to HP, this line is 80 mm at an angle theta. The front view appears as a 80 mm inclined line, whereas the top view appears as a 65 mm shortened length according to the question. When a line is inclined to VP, the top view appears as a true length of the line, that is 80 mm, but when you see from the front it appears as a 55 mm. You can see that here I noted as midpoint M dash and M, here also M dash M, exactly this is the midpoint. So now let us see how to draw the projections. So in the question they gave that the midpoint is 30 mm above HP and 35 mm in front of VP. See, 30 mm above HP, 35 mm in front of VP. The same I am going to draw. 30 mm above HP, 35 mm in front of VP. Okay, so in this question to draw the true length, we know the length but there is no angle, theta they didn't mention. So indirectly they gave the projection, top view length as 65 mm. You can see that the top view is 65. From the midpoint it is 32.5, 32.5, exactly at in front of VP distance, because its projection falls on here in front of VP distance. So take the line 65 mm, move, yes, so this is the point. So just to draw the true length I am extending the projectors. Okay, now take the circle, because this is the midpoint of the line, so the radius will be the 40, because question length is 80 mm, true length. And now from here to here, perfectly it passes through the midpoint. Okay, yes. Now this related to the horizontal plane inclination theta. Okay, let me name P dash, Q dash, and this one as M dash, midpoint. And now this one as P, this as Q, and this one as M. Okay, now we finish the horizontal plane inclination projections. One more is that when a line is viewed from the front, it appears as a 55 mm. When a line is viewed from the front, it appears as a 55 mm. It says that this line is inclined to vertical plane at an angle of pi. So what I am going to do is that take the line 55 mm. move this object. Yes, so this will be the point 55 mm. Again I am drawing the projectors to draw the true top view length. Okay, yes, now take the circle, and this is the midpoint, right? Okay, the radius is 40. From here to here, see, exactly the line passes through the midpoint. Perfect. Okay, so this is the vertical plane inclination projections. Perfect. So let us give the names. Here I am taking it as this one. First I will give. In the previous tutorial, end P is fixed, so that's why P dash and P is common, but here midpoint is fixed, so that's why I am giving the new notation P1 Q1, and its corresponding front view is Q1 dash P1 dash. Perfect. Now we finished the horizontal plane inclination projections, vertical plane inclination projections, front view and top views. Now let us draw the locus lines. Okay. Locus of Q dash. This one is locus of P dash. This one is locus of P1. Yeah, we'll name it. Locus of P dash. Locus of P1. Yes, now we finish the locus lines. Just we will rotate the shortest front view to true front view locus. See that from this diagram you can see that true front view is P dash Q dash, and the shortened top view belongs to the this one, so that's why PQ, and the true top view is P1 Q1, and the shortened front view, its corresponding front view will be the shortened one, P1 dash Q1 dash. Yes, so now I am going to rotate this shortened front view to true front view locus. Arc, enter, center, taking this as the center because midpoint is fixed here and this is the radius. Yeah, so it cuts till here. Again arc, because I rotated only the half of the line. Now I am going to rotate the other half of the line. center, this is the center, and this is the radius, and it cuts here. Perfect. Now you can name this one as Q2 dash and this one as P2 dash. Okay, so you can draw the line from Q2 dash to P2 dash. See, exactly the line passes through the midpoint. Okay, we'll do the next step. Rotate the shortened top view to true top view locus. Arc, enter, center, and this as the center and this as the radius. I am rotating here. Press the control key for the reverse direction. Okay, it cuts exactly here. Arc, enter, center, and this is the center point and this is the radius. You can cut here. Press control key. Perfectly it cuts here. Now we'll draw the line. It cuts from here to here. See, exactly the line passes through the midpoint. Let us give the notations for this one. So this one will be the P2 and this is Q2. Okay, so if you observe carefully, the line P2 dash, M dash, Q2 dash is the final front view. Final front view. That's why you can see exactly it passes through the midpoint without any deviation. And now the final top view is P2 M Q2. Exactly the same line passes through the midpoint without any modification. 0.35. Okay, so as we saw in the previous tutorials, how to confirm that whether we did right or not. Just we need to draw the vertical line between the endpoints. You can see that Q2 dash and Q2, it will be a 90 degrees ortholine. Says that these are the projectors between the front view and top view. If you observe carefully, in the previous tutorial, there will be only two projectors, that is belongs to the endpoints of the line. Q2 dash to Q2, P2 dash to P2. Here you can see one more projector between the M dash and M. See, this is also exactly a vertical line. This one and this one. One more line I am going to draw between the P2 dash to P2. See, perfectly 90 degrees. It says that we did the correct procedure. So now, according to the question, we need to find out the apparent lengths and apparent inclinations. DAL, dimension aligned 55, 65, dimension angular. So between this one to, I am taking as a reference line 58, from the reference line to this one 63. If you observe carefully, in the previous tutorial also you got the same inclination and same lengths of the apparent. Apparent length is 55, 65, 58 and 63. So it says that though the position is different, either the midpoint or end point, the projections will be same, and especially depends on the inclination angle. So that's it. So this is how to draw the projections of a line when they give the shortened top view and shortened front view lengths.